Hi guys, today we are going to start talking about solubility curves. So what I'm going to do is I'm going to find my solubility curve and show it to you. First thing we need to remember is, what do we know about solubility? Solubility is the ability to dissolve something, okay? So the first thing we need to step back and talk about mixtures. We talked about mixtures way back in September when we were classifying matter. First thing we need to do is matter. What is matter? Matter is anything that has mass and takes up space. It must have those two things in order to be matter. Then we can classify matter as whether it's a pure substance or a mixture. What's the difference between a pure substance and a mixture? Pure substances are two or more elements or atoms that are chemically combined, whereas a mixture is two or more atoms or pure substances that are physically combined. So remember, I used the example of hydrogen and oxygen. I throw them into a blender and they are not going to make water because I physically combine them. I would have to chemically combine them in order to make water. Then we can break our pure substances down into an element and a compound. What's the difference between an element and a compound? Elements are those wonderful, beautiful things on the periodic table. Elements are just one single atom, whereas compounds are two or more atoms chemically combined. Again, you need to remember that compounds are chemically combined. We then could go on the other side to my mixtures. Mixtures can be broken down into homogeneous or heterogeneous. What is the difference between a homogeneous mixture and a heterogeneous mixture? Homogeneous mixture is when it's the same throughout. However, be careful with that, because just because we have two things like sugar and water together, it does not have to have the same amounts of sugar and water in order to be a homogeneous mixture. I can just have one tiny tablespoon of sugar in a whole cup of water. That would still be considered a homogeneous mixture. Homogeneous mixtures, they are very uniform, meaning every sip that I take out of my cup, I would have the same amount of water and sugar. Now, on to what is a solution. A solution really is a homogeneous mixture, like my sugar and water. Okay, there are two parts to a solution. We have our solute and our solvent. Solute is the thing that is being dissolved, and the solvent is the thing that is doing the dissolving. So if I take, for instance, my tea, I make a cup of tea and I want to put sugar in it. So I would then make a solution because something dissolves in something else. In that example, what is my solute and what is my solvent? In my cup of tea, my solute is the sugar because that is the thing that is doing the dissolving, or that is the thing that is dissolving, and my tea is the solvent. That is the thing that is doing the dissolving. So, and before we go any further, we need to remind ourselves about a few things. Something that is soluble, that is a substance that dissolves another substance, okay? Meaning it will dissolve there. Something that is insoluble, it's a substance that does not dissolve another substance. Miscible is when we take liquids and they're completely soluble in each other or can mix, meaning you would not be able to tell the difference between them. Say my coffee and my creamer. Those are two liquids that I'm combining together and they can mix. Whereas then something that is immiscible, these are liquids that are not soluble. Say, for instance, your oil in your water, what you saw in lab last week. So when we talk about solubility, what is solubility? Solubility is the amount of something, solute, that I can dissolve in my solvent. This is an actual exact number. Take my tea, for instance, again. I cannot add a whole bunch of sugar to it and it will always dissolve. There is a point where there will be no more sugar dissolved in that tea. This is referred to as solubility. Okay, there is a maximum number of grams of solute that will dissolve in 100 grams of solvent at a given temperature. I can actually change the solubility if I change the temperature. In the example of my tea and my sugar, how do you think I could get more sugar dissolved in my tea? The way to do that is to change the temperature. Okay, changing the temperature would increase the solubility, meaning if I heat it up, I boil the water, I can actually fit more sugar in my tea than if that water was just at room temperature. When we talk about solubility, we also talk about a solution being saturated, unsaturated, or supersaturated. A solution that is unsaturated, that means it is below that maximum amount, meaning I can put more sugar in my tea. More will dissolve. When I'm a saturated solution, saturated means it is at that maximum amount. I cannot dissolve any more sugar in there. Supersaturated means that it is actually holding more than it truly should be able to dissolve. Okay, if I had 3 beakers sitting on the table, all a solution all filled with tea and sugar, how would I be able to tell whether one is unsaturated, one is saturated, and one is supersaturated? In order to do this, we actually put what we refer to as a seed crystal in. You actually did this in lab yesterday. Excuse me. When you put a seed crystal in and it dissolves, like this first test tube right here, I throw a seed crystal in and you see that there's nothing there. That means that that solution can hold more solute than it has right now. That means that is an unsaturated solution. If I throw seed crystal in the second test tube, and you can see that that seed crystal sinks to the bottom, that means that it is holding its maximum. It will not dissolve anymore. So that would be a saturated solution. It is holding its maximum level. In my third test tube here, I throw a seed crystal in, and you'll see that it's actually, there's more crystals in there. It crystallizes. That means that this solution, it was so unstable that when I threw the seed crystal in, it actually pulled out some of the solute that was in the solution to form these crystals. It was holding its more than what it should have been. This is a super saturated solution. You actually did that in lab yesterday. You made an unsaturated solution, a saturated solution, and then at the very end, when you threw that seed crystal in, you held a super saturated solution. Think about in lab and the procedure that you went through. How did you make that super saturated solution? The way that you made that supersaturated solution, remember, is you heated it up. And remember when we talked about solubility a few minutes ago, in order to increase the solubility of something, you need to increase the temperature. So what I have shown here is actually what we refer to as a solubility curve. Now, notice there are tons of different lines on here, but you'll notice that each of these lines are different for each substance. So let's take a look at my sodium nitrate line here. This is my green line right here. Okay. If we're on any point on that line, that means that I would have a saturated solution, okay? Meaning it is holding the maximum amount of solute that it can hold at that particular temperature. If you are at any point below this line, okay, so any of these points down here at any of these given temperatures, that means that you are an unsaturated solution. You are holding below the maximum amount. If you just think about these words, they make sense. Unsaturated, you are under that line. You are holding less than what you really should have. Sorry, guys. If you are at any point above this line, okay, you are holding more than what you really should be able to hold. So that would be a super saturated solution. So the thing you need to remember, if you are on this line, you are at the maximum. That is a saturated solution. Anything below the line would be an unsaturated solution. You are holding less than what you really should. Anything above the line would be a super saturated solution. Okay, so pretty much it's just you need to know those three parts of that graph and what that line really does mean. Okay, and that is all about solubility. Okay, I hope you guys learned a little bit of something, and we will see you guys later.